Okay, we've talked about adding and subtracting and multiplying polynomials. So now, of course, we're going to do dividing polynomials. Now, just like when you're multiplying a polynomial by a monomial, that's pretty simple, and it's something we had already done. Same for dividing a polynomial by a monomial. If you're dividing by a monomial with one term, then you can just separate and divide each term individually, right? So if I had 2 plus 5 divided by 3, I could separate it and just do the 2 divided by 3, 5 divided by 3. X divided by 2y, 3z divided by 2y. And then if you have fractions or anything that can simplify, you simplify it, you've done the division. So let's look at one. Okay, divide this trinomial by this monomial. Because it's being divided by a monomial, I can just divide each term by that monomial. Just like when we multiplied each term by that monomial. Now we're going to divide each term by that monomial. And now that we don't have any plus or minus signs in each fractional part, I can simplify that. Right? Remember, if you have something like this with a plus in between, you cannot divide that out. Right? This is 5 halves, 2 1/2. It's not 3. So be careful with those plus signs. But I've separated it, and in each term then I don't have any plus or minus signs. So I can just treat that like reducing a fraction. So 12 divided by 6 leaves a 2. And then remember our rules for exponents. 6 m's on top, 2 on bottom. So 2 of them can cancel out, or you can say 6 minus 2, m to the 4th. 18 divided by 6 leaves a 3. Okay, and 5 m's on top and 2 on bottom. That'll leave 3 on top. 30 divided by 6 leaves a 5. And then m fourth divided by m squared leaves an m squared. So dividing by a monomial, right, pretty short and easy. If I can just remember what to do for the first step. Just divide each term by that monomial. And it could be written in multiple ways. Here's another way it could be written. As this stands, I cannot do any canceling because I've got these plus and minus signs. So nothing can divide out with a plus or minus between it, but I can divide each term individually by that monomial. Okay, 50 divided by 10, that's 5. M fourth divided by m cubed is just an m. 30 divided by 10, 3, so there's a minus 3. And m cubed divided by m cubed, anything divided by itself is 1. 20 divided by 10 is 2. And there's not any m's, so that m cubed stays where it's at. It doesn't simplify any. Okay, now it's saying divide this polynomial, trinomial, by this. Same thing if you're just dividing by a monomial. Just do each term individually. Okay, now what I got to be careful of here is look what I have really. 2 negatives, so this is a positive. And 8 and 3 don't simplify any. So my coefficient for that is just going to be that fractional 8/3. And I've got a p on the top. I can either write it here beside it, or I'm just going to, so what I mean is I can either write it like this, 8/3 p, or I can leave the p in the numerator with the 8, whatever you prefer. Now once again, there's a double negative, 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 so that's really a plus. 6 divided by 3 is 2, and the p's completely divide out. Negative, negative, plus. 12 divided by 3 is 4, and a p squared. Okay, so dividing by a monomial, pretty straightforward. It's dividing by another polynomial that gets a little complicated. So if we're going to divide a polynomial by another non-monomial polynomial, we're going to use long division. Okay, so let's review our process of long division. Let's say, what if we have 678 divided by 5? Let's go through the steps. First of all, if I knew how many times 5 went into 678, I wouldn't have to do long division. Since I don't, I'm going to try just looking at this first term. Well, how many times does 5 go into 6? Oh, one time. You put it right above the digit you're dividing into. Now remember, when you're doing long division, keeping your column straight is really important. Then the next step is you multiply 1 times 5, and you write it right here. Then you subtract. And then you bring down. Then you divide again. 5 goes into 17 3 times. I'm going to write it above this term. You multiply. 3 times 5 is 15. Then you subtract and bring the next one down. 5 goes into 28 5 times. You multiply. Then you subtract. And when there's nothing left to bring down, one option is to add a decimal and some zeros, but that doesn't make sense to add a decimal to the last term of a polynomial. So our other option is to leave our remainder as a fraction, where this remainder is the numerator of your fraction and your divisor is the denominator of your fraction. These are going to be the exact same steps we're going to do to divide a polynomial. So if you get lost, make yourself a small problem like this and do the exact same process. Now, if you have polynomials, first of all, we've got to write them in descending powers, and there can't be any missing terms. So the first thing I'm going to check is to make sure my exponents go down with no numbers missing, and they go all the way to 0. So 2, 1, 0, 1, 0. Check each one individually. So I'm good with that, right? It's got to go from the biggest down to 0 with nothing missing. So then if that's the case, I can put it in my division bracket and do those same steps we were just talking about. Now remember, I don't know how many times x plus 5 divides into that, so I'm just going to look at my first term. How many times does x go into 2x squared? Okay, so you can think about this a couple of ways. You can go over to the side and you can say, well, what's 2x squared divided by x? One of these x's get to cancel, it's 2x. Okay, so you can go over to the side and do the division. Or you can ask yourself, and here's what I do. What do I have to multiply x by to make it 2x squared? Well, obviously I need to multiply by 2 to get the 2 in there, and then I need another x, right? Same thing, so however you want to think about it. Now, once I have written my term up here, remember the next step from our division problem, then you multiply this times this, and you put it under here. So 2x times x, 2x times 5, And now this isn't always the case when we have just numerals, but if these numbers are not identical, you got the wrong number up there. You better get the identical thing right here or you won't be able to do it. Okay, after you multiply this times this, then you subtract. Now, when we subtract, we have to remember I'm subtracting this whole polynomial. So another way I can think of subtract is, because if I distributed here, that'd make a minus and a minus. So it is the subtract process, but I'm going to say then, I'm going to say then change the signs. That's our subtracting. Okay? Now this is gone, and it better be gone every time or you've messed up. 5x minus 10x is minus 5x, and then you bring the next one down. Divide again. What do you got to multiply x by to make it negative 5x? Oh, well, that's easy. Negative 5. Once you figure out what goes here, you multiply. Negative 5 times x, and those better be identical, so I feel good about that. Negative 5 times positive 5. Then you subtract, which in this case means change your signs. Okay, now that's gone, and that's gone. That's 0, 0. When there's nothing left to bring down, you're finished, and because my remainder is 0, I have my answer. Okay. Now, just like any other division, if you want to, you can check this by multiplying them back together. This times this better give you 2x squared plus 5x minus 25. All right, so let's try it again. It's the same steps over and over and over. 3, 1, 2, 0. I don't have anything missing, but they're out of order. So I got to rearrange that when I write it. And 1, 0 is good there. So here we go. 2x cubed plus x squared plus 5x plus 13. Divided by 2x plus 3. All right, double check. 3, 2, 1, 0. Okay. What do you got to multiply 2x to make it 2x cubed? Oh, I need 2 more x's. If I just have 1 right here and I need there to be 3, I need 2 more. Once you figure it out, multiply x squared times 2x. 2x cubed better be the same. It is. X squared times 3. 3x squared. Now you subtract. Change the signs. Okay, now that's 0. X squared minus 3x squared is minus 2x squared. Bring the next one down. And then divide again. What do you got to multiply 2x to make it negative 2x squared? Okay, I need a negative sign in there. And then I need one more x. Negative x times 2x is negative 2x squared. So that looks good. Negative x times 3, negative 3x. Then you subtract, which means what? Change the signs. So that better be 0, and it is. 5x plus 3x is 8x, and then you bring the next one down. What do you got to multiply 2x by to make it 8x? Okay, 4. Okay, 4 times 2x is 8x. 4 times 3 is 12. And then you subtract. Change the signs. 13 minus 12 is 1. Notice this time I didn't get a 0. Right? I didn't get a 0. So I have a remainder. And remember what we did with the remainder. Now before, if it's just a number, if I see a number like this, I know that's 5 and a half. It means 5 plus a half, right? 5 and a half more. When we have variables, though, and we put numbers right next to our variable, it means multiply. So I got to be careful and say, hey, I don't want to multiply this 4 times my remainder. So I'm going to put a plus there. 1 over 2x plus 3. Okay, so I've got this remainder. Don't write it right next to your number. It'll mean multiply because there's a variable in here. And we want it to be, oh, it's this plus a fraction bit more. Okay, now I've got some missing terms. This one goes from 3 to 0. So when I write it, I've got to tell the problem that I do not have any square terms or any linear terms. Let's double check. 3, 2, 1, 0. Okay. X minus 2 is fine. It goes from 1 to 0, so I don't have any worries there. All right. What do you got to multiply x by to make it x cubed? I need 2 more x's to get 3. So x squared times x is x cubed. X squared times negative 2, negative 2x squared. And then, you got it, change your signs. Okay, 0. 0 plus 2x squared is 2x squared. Bring the next one down. What do you got to multiply x by to make it 2x squared? Yeah, I need the 2 and I need another x. So then multiply it. 2x times x, 2x squared. 2x times negative 2, negative 4x. And then change the signs or subtract. 0, okay, 4x, because 0 minus 4x is plus 4x, right? Subtracting a negative is a positive. What are you going to multiply x by to make it 4x? 4. 4 times x is 4x. 4 times negative 2, negative 8. Subtract or change the signs. And both of those are 0, so I don't have a remainder on this one. But there's my quotient, my answer. All right, one more time. 4, 3, 2, 1, 0. Okay, but uh-oh, look at the divisor. It goes from 2 to 0. So I got to fill in my placeholder there. All right, so x to the 4th minus 3x cubed plus 4x squared minus 5x plus 3. That's all good. 4, 3, 2, 1, 0. But I'm going to divide by x squared plus no x's, I have to tell the problem, plus 2. Okay, 2, 1, 0. Okay, what do you got to multiply x squared by to make it x to the 4th? X squared. X squared times x squared is x to the 4th. X squared times 0 is 0. And you can put 0x cubes there if you want. It doesn't matter. I guess I will just for emphasis now, but it's 0x cubes. X squared times 2 plus 2x squared. Now we subtract, which means change your signs. That's 0. This is negative 3x cubed. And this is 4x squared minus 2x squared, 2x squared. And bring the next one down. What do you have to multiply x squared by to make it negative 3x cubed? Right, we need negative 3x. Right, because I already have 2 x's here. I just need there to be 3, so 1 more x. Then multiply. Negative 3x times x squared is negative 3x cubed. Negative 3x times 0 is 0. technically 0x squared if you prefer. Negative 3x times 2 minus 6x. Now we subtract, or in other words, change the signs. Okay, this is 0. 2x squared minus 0 is 2x squared. Minus 5x plus 6x is plus x. And bring the next one down. Okay, that's how you know you're finished, when there's nothing left to bring down. Now, what do you got to multiply x squared by to make it 2x squared? That's right, a 2. Do that multiplying. 2 times x squared is 2x squared. 2 times 0 is 0. 2 times 2 is 4. Change your signs. Okay, so that's 0. X minus 0 is x, and 3 minus 4 is negative 1. Now, there's nothing left to bring down, so this is my remainder. So it's going to go over your divisor. I don't need that 0 in there any longer to write my answer. It's just a placeholder for working the problem. But don't forget, I got to put a plus there. I got to separate this from that number, or else it'll mean multiply. So x minus 1 over x squared plus 2 is my remainder. Okay, let me know how that goes for you. I'll see you next time.